Hello, everybody. I'm Alexey Krabrov, the founder and organizer of AI by the Bay, the longest running, deepest technical, independent open source conference, which is being held for 11th year in the Bay Area. It used to be called Scale by the Bay and Data by the Bay. We do different editions. And today we have a very special guest, Tyler Jewell, who is the CEO of Akka. It's a company with a long history and a long relationship with Scale by the Bay and Scala by the Bay. It used to be called TypeSafe, and Lightband went through an evolution. And at its core, it has very robust distributed systems framework called Akka. So now it's actually called one of his products. So very happy to have Tyler here. Welcome, Tyler, and tell us a little bit about yourself and what was your path with TypeSafe, Lightband, and Akka, and why did you join Akka as the CEO now from an investor, and how do you see the future of Agentic AI with Akka?
Well, thank you for having me. It's a real pleasure to be here. I am the CEO of Akka, and the company's 15 years old. It started off as TypeSafe, founded by Jonas Bonnet, who is the founder and CTO. And it was originally intended to be a development framework to make it simple to build massively concurrent systems on multi-core compute. And 15 years ago, that was a really difficult problem. Blocks, threading, you had to have practically a graduate's degree in order to understand it. And Jonas used 1970s computer science actors in order to implement his form of compute. And actors offer a really nice form of supervision and message passing, asynchronous message passing in a secure, isolated way, which offers forms of resilience and lightweight compute. Turns out that Akka, as a multi-core compute unit, works equally well if you think of it as supporting microservices that are operating over a network. And it became a full-fledged distributed systems framework where you actually push logic and data into the microservices, and those microservices run in large clusters close out to the edge. And that offered some incredible outcomes for people who made use of the framework, where you could get ultra low latencies for accessing your data, either from reading or writing, the 6 nines of availability because the system was spread all over the place, along with massively concurrent numbers of end users because you could make as many replicas of the system as you wanted. And I joined as an investor in 2019, a board member, and really saw an amazing potential with the technology in the company. And what had happened is we had a huge base of blue chip accounts. There's about 100,000 systems that have been built with Akka over the years, 1.5 billion downloads. And on any given day, 2 billion people use an application that has Akka under the covers. And it always seemed to just work, but it was also plagued with some complexity and some challenges. So there was a long learning curve with it. And working with Jonas and the team, we saw a tremendous opportunity to transition it from a development framework to a platform that could really simplify how you build these systems, but also have high velocity with very quick, rapid delivery cycles. And that opportunity was just so big and massive that I wanted to get involved with it, and I joined the CEO a couple of years ago. Interestingly, when we originally delivered this platform, it was intended for application modernization. That was the sort of use case. But along came Agentic AI, and about a year ago, we had a number of our larger customers come to us and tell us that they had started to build Agentic AI systems using Akka. And we were very curious by that, and we became a little bit of some Uber geeks in and around that particular domain. And what we discovered was that Agentic AI is a distributed system. What you're dealing with are lots of agents that have to be coordinated over a network. And these agents have some sort of shared goals, which is distributed state. So now you have a distributed system at the heart, now backed by a stochastic LLM, which is very unreliable. It was a perfect fit for us. And we've since pivoted and kind of really zeroed in our platform to be specifically an Agentic AI platform now.
Fantastic. Thank you for this overview. And I just, might add that, I've, seen TypeSafe, Lightband, and Akka folks going through this whole arc, right? Because distributed systems are very complex, as you mentioned. And for a lot of folks who come into Gen AI, right, like they see tip of the iceberg, they see few scripts in Python, and they kind of hope it's going to work if they unleash a bunch of agents, right? But, to somebody who's been around the block a few times, it seems to me like it's mostly distributed systems, right? So the logic of interacting with the lambs, you send strings to it and then get strings back, right? Which is also, better done in Java probably because it's more reliable. Oh, but if you look at this mix, so you guys, and I talked to Jonas, right, at JFocus in February, right? I went to Stockholm as a AI community architect at Neo4j, now the Swedish company, and saw Jonas and Akka, and we had a conversation with him. We had an interview, right, and we talked about this agentic vision. So I think it's clear to folks who've been in the field that this is a match made in heaven. But if there are some new folks, how do you see what's the mix of AI versus distributed systems? How much in this customer application do you see people actually spending time building distributed systems and all this logic?
Well, if you were to listen to the media, the media would have you believe that everybody's building agents, and if they're building those agents, they're probably doing it in Python today. And actually, it's really not quite that. Is a a bit of a far stretch on the truth of what's really happening on the ground. What has happened is that desktop tools or desktop applications where you can build local agents that make use of local tools has really grown and exploded. But that's not the same as an agentic system that's going to run inside the enterprise. Within the enterprise itself, what we've laid witness to is every organization on the planet either researching, learning, educating, maybe testing and prototyping, but a very, very small number of them actually building systems that are truly agentic systems at the end of the day. So it feels like that the market is still in its first inning, in its earliest stages that's there. And the development that does happen, it's oftentimes happened as a graduation of the data science teams. So you have these MLOps teams or the data science teams that were responsible for working with the data and the models. And of course, Python is a great language for building models, training models, and working with them. And so it was just like this natural extension where those teams, those data science teams said, agents are going to call the models, so therefore we must be responsible for the models as well. And so you see all these Python frameworks that have emerged. But what's happening in reality is that as these agents transition from prototypes to systems that need 24/7 operations that are resilient, that never fail, suddenly the CIO is raising their hand and saying, hey, wait a minute, this is a different type of domain. My organization is well equipped to handle that. And as that transition takes place, you're going to see the growth of Java and other languages that have proven operation properties that exist for agentic systems.
That's great. So, the main theme of AI by the Bay 2025 is reliable AI, right? So we basically want to emphasize various technologies such as distributed systems. So I remember I learned, to huge surprise that Era, right? Like Era is the most widespread Wi-Fi mesh and home mesh. I think it was one of the biggest Akka customers. Behind every Era device, there is an Akka actor, right? So I'm just wondering, I think you have a huge advantage over a whole bunch of this agentic new, Pythonic frameworks because they're aspirational. Like they hope you're going to adopt them, but Akka is already in production. So it seems much easier to add AI to already existed robust distributed system. So I wonder if you can talk a little bit about, some customers of Akka which already are out in the field and like if they're doing POCs, thinking of POCs, what would make good experiments for the existing customers?
Yeah. So we have about 45 customers in production with agentic systems now, which is, we're kind of thrilled. We're over the moon with that because these are hardened systems that's there. And on top of that, we just signed last week our first big competitive win against LangChain. So in an account that had only Python developers inside of it, and we were able to convince them that a Java framework was the way to go. So our message is definitely resonating. We're pretty pleased. In terms of some of the accounts that I can speak to, one is Swiggy out of India. They built a personalization and a traffic routing system that uses models to do recommendations on that. And they had a sub 100 millisecond round trip latency requirement. So they needed to build a custom inferencing layer. So they used basically a giant Akka cluster as that inferencing layer. And another company who I don't know if I can mention, Tubi, which is owned by Fox. Fox, they built a real-time personalization engine that will make content and advertising recommendations for users with this continual feedback loop. And they implemented agents that have over a half dozen models. And it's sort of this sort of continuous real-time streaming mechanism that's also making use of models behind the scenes. And so that we're really proud of that. Later today, I'm signing a new platform deal, new AI platform deal for the UK's largest payments processor. So this is a fintech. This is probably the first fintech that is going to go down this agentic path. And I think in the next 2 months, we're going to sign another almost 10 deals as well. And these are all large enterprises, retail. Let's see, who else? Health insurance as well, life insurance, and medical devices. So these are all enterprises that are going down this path. And most of them are Python shops that are now converting over to Java.
Oh, I have a personal question. I spent last 3 years trying to convince Python developers that they should not use Java frameworks. Even though, as a software engineer, I was a Java developer, Scala developer. I used Akka actually in production. Back when I was working for Expedia, we used the actor system. But here, an important thing I think to mention for our listeners is that you're not convincing Python developers to write Java bare hands, right? You talked about the platformizing, making a platform of Akka, and that's what helps them to choose between LangChain and Akka. Is that correct?
Well, when we personally sell into the enterprise, we have kind of a three-pronged value proposition that we give to them. And the value proposition is we can get you into production quickly, we'll keep you there safely, and then we scale cost effectively. And we can demonstrably prove that we are higher velocity than Python-based frameworks, that it's safer, that it's more secure, and that the cost of scaling is way cheaper. And so let me just break those down and how we do that. And so the language that you use is irrelevant because these other values to the enterprise matter more at the end of the day. Now, how do we get you there quickly? The first is that all the Python frameworks are just that, they're frameworks. And the thing about frameworks is that they still force you into composition of the system itself. So you have to piece together the agents, the memory, the orchestration, if you want streaming or APIs. These are all different piece parts, and you got to find a way to make them work together. They have different development approaches, testing philosophies, integration, CI/CD mechanisms, packaging, and deployment. With Akka, we take a systems approach now, and that we look at the entire agentic system as a uniform bundle of a service that you're going to deliver against. And our SDK gives you declarative ways of defining what that system is with very basic Java programming. But more importantly, we uniformly approach development, unit testing, evaluation, integration testing, packaging, deployment, all as a single unit. And when you treat it as a high velocity unit that way, you end up having a lot fewer bugs. The Java ecosystem for modules and third-party dependencies is safer. It's a more trusted SBOM that you're able to build. And then because there's also a standard way of packaging it, you have mechanisms where you can do rolling updates with this in real time as well. And so this is all this benefit comes down to the fact that you can make lots of improvements on a very short order. Now, we'd actually argue that our SDK syntax is as simple as the Python syntax now. And because of the way that we've structured our SDK, it's so tightly constrained. There's only one way to do everything in our SDK, which means that we can feed it into AI like Gemini or Claude Code or whatever it is. And the AI now generates entire systems without hallucinating. So you can get started with this and start building. So that's the get it there quickly. I can elaborate on all the things we do to keep you there safely, but it's about having a compliance and regulatory process that allows you to build trust. There's a very special technique in which how you trust these systems. The systems are based on unreliable networks and unreliable LLMs, so trust and governance is so critical on this. And then on the scaling more cost effectively, because of the JVM and the way that the bytecode interpretation works and our actor model, one core of Akka is 5 to 7 cores of Python in LangChain. And so when you're looking at your cloud compute costs, you're saving anywhere from $2,000 to $4,000 a year just on the raw compute costs because of the efficiency and the density of the systems that we can run. You put that in front of hiring managers, executives, and it becomes a choice between, do we want to go with the language that is the most familiar, or do we want to go with the system that's going to be the cheapest and the safest?
So from my experience, a lot of times people are like Python developers are not afraid of the language itself, but more about the JVM ecosystem, things like garbage collection and overall distribution, etc. So that this is what I think they struggle more with. Because the syntax is you can easily fight that right now with all kinds of copilots versus like with the Plex distributed system. Yeah,
to a degree, but with Akka, we've hidden almost all those complexities. Garbage collection, threading, asynchrony, all those things. And what ends up happening with the Python developers is they think that it's really simple to get started. But the moment they want to have any sort of concurrency with that, they're also now wrestling with the global interpreter lock. If you want to run multiple processes concurrently, it's like a megabyte of overhead for each one, whereas it's like 4 kilobytes of overhead for actors. And the Python runtimes aren't inherently resilient, meaning that if there's failures in processes, there's got to be some other supervision that is managing against that. And those are all just solved problems inside of the frameworks that we have inside of the JVM today. So really this SDK, we've simplified it down so that yes, you might have to learn a new language, but now you're just a bunch of day 2 issues that you just don't have to worry about anymore. And that wins. When we can get to the bake-off plays very well.
That was a little derail. Sorry about that.
Yeah, it's all right.
No, that was a good question. I have a couple of follow-up questions. So first, Tyler, again, this is the first conversation we have, and I knew you as an investor from Dell Capital. You're very deeply technical. Can you tell us a little bit why did you invest in Lightband, and what is interesting to you in this space? How did you come to play in the distributed systems playground? So you know all the issues and costs and technology and so forth.
Yeah, I ultimately invested originally as it was 2019 when I invested, and there was 2 reasons that at the end of the day, which was one is there was just no other technology on the market that could make the guarantees that Akka could make, and it was proven. Not only could they make the guarantees, but it was proven. Everything from Starbucks to Datadog, Walmart, Apple. You name it, we've kind of run some of the world's largest distributed systems at this point. And then the second reason was that there seems to be massive adoption. At least at the time, it felt like there was a lot of massive adoption. This is still when the product was still pure open source. And a lot of that adoption was coming from the Scala community. And so the investment reasoning was unbeatable technology and probably a really big market. At the time, the business model didn't work out the way I thought when I first invested into it. And that the adoption was there, the technology was definitely proven, but because it was open source, it was very difficult to convert all the adoption into a commercial business. And so that didn't play out against my hypothesis the way that it did. And we've had to basically, to solve that problem, we had to move away from being a development framework into a pure platform play, stop selling to developers and instead sell to senior executives that have to buy into outcomes. And then we ultimately changed the licensing model from open source to non-open source as well.
Which follows majority of SaaS offerings, right? So this is not surprising. This is pretty much a norm. So another thing, I had a question. I think you mentioned a fintech POC, and that's interesting to me because I noticed that banks are very conservative. They basically run on JVM, right? And so it's interesting to me that, for compliance reasons, security reasons, right? They're very paranoid. You cannot just bring a jar into a bank, right? It will be put on the surgical table, disassembled, looked at, put together, right? It's not as easy as people think. You cannot install stuff, right? You cannot, use Maven to install stuff. You have to go through, jump through hoops. So to me, it signifies that, it may be actually a very good pre-existing condition that fintech is run on JVM. So I knew, companies like Tally, they actually selected JVM intentionally, right? And others too. If you are in a startup you want to be in JVM because you're going to eventually exit by selling to a big bank, which already runs on JVM. So do you see this happening, and how do you think it's going to affect adoption of agentic frameworks?
So we operate in 52 banks around the world, and about 28 or 29 of those use us for payment on that. So a large number of the world's payments are Akka influenced at the end of the day. And what really defines the fintech environment is really a fear of loss of data at the end of the day. And so they absolutely need guarantees that there's never going to be any sort of data corruption. And on top of that, meaning you can always recover from any possible anomaly that's there. And then you've got to layer in the fact that no outsider or no one who is not authorized to have access to that data should ever have access to that data. And so those are really the things that drive them at the end of the day. And the JVM, and it's not just the JVM, but it's also the way the JVM ecosystem, when you look at how all the different vendors go into contributing to the JVM, and then all the modules that are on top of that, they are, it's kind of a trusted ecosystem that has been managed by the commercial vendors themselves. It's not by open source developers in that sense. And so the supply chain, if you will, is as safe as the application inside of it. And so it's a combination of like frameworks like Akka that have been able to prove and demonstrate that it's impossible to corrupt the data, that it's impossible for us to get access to that data, combined with this kind of safe, secure supply chain of all the modules that make it possible for the fintechs to make use of this. I think that the fintechs are a recognition of what's going to happen across all the enterprises, which is, I think that at least half, if not 3/4 of all the agentic systems will probably be built with Java. I think that the models and the model training and the model inference will probably continue to be Python because there's no need for that to be a JVM, but the applications that make use of those models, there's really no reason why you would want that to be Python. You would almost always want that to be a JVM.
Absolutely. I mean, most of this, training setups are commodity, and once you have the model, the real question is what are you going to do with it, right? And like there are many ways to run models, and there are many providers competing on costs, so it will effectively become a commoditized resource. Again, Baskin is a fellow Swedish employed person, so Akka is a name for folks who don't know. It's the mountains in Sweden, right? So the original team named it, and I am now, AI communicator Neo4j, which is another Swedish company, also on JVM. J stands for JVM for folks who remember this. And interestingly enough, right, we have a very similar situation where there is, Neo4j was the original graph database, and now there is a million graph databases, but Neo4j dominates the market. Very one simple guarantee that we're not going to lose your data, which is kind of important, right? If you are a database, you can be very fast. You can be very easy, you can be very convenient. At the end of the day, if you never lose data, like we'll compromise on speed, we'll compromise on whatever, but we'll not lose your data. Another interesting parallel to me is that the enterprise version, we have an open source community edition, but the enterprise version has all the permissions features, like you mentioned, right? Like, which is really important. So I can see a lot of parallels. So maybe you can talk a little bit about the origins of Akka, and Jonas Bonner, right, who is the visionary behind Akka. I just wonder, like, he's the CTO, he spoke at Scale by the Bay, he's a creator of Reactive Manifesto. Can you talk a little bit about the kind of intellectual, capital behind Akka, all this kind of things which Jonas and others did, which led to this point in time?
I think what is the brilliant part of Akka's principles is that if you want to build a system that never fails, you really have one of two choices. You have one or two basic design philosophies you can take. One design philosophy is to maintain the state of the system as a durable record that is always accessible, right? That's the temporal approach, the durable execution approach, right? Because you can maintain the entirety state of the system as a durable record, you can always go back and recover the system and then continue on. So it's provably works, but the downside of that is it's really slow because every kind of state update requires you to go to some central point and go get access to that, and then it becomes a single point of failure. So simple to understand, but really slow at the end of the day. The other design philosophy is to say, no, the application itself needs to take responsibility for its own outcome, which means that it needs to divorce itself or decouple itself from all of its underlying infrastructure and has no dependency. And so that it looks at persistence and compute as commodity resources that are available to it. And this is the approach that Jonas takes. And so when you take this approach, what you start doing is I'm going to design a distributed system where you make the assumption that uncertainty is abound, that whatever can go wrong will go wrong, that I cannot anticipate whatever is going to happen, and that the system itself has to be independently capable of observing the problem and then adapting to whatever that problem is presenting itself, whether that's a hardware failure or a network disruption. And so when you do that in his logical mind, you have these distributed nodes. They're running in these large clusters, but the application itself takes responsibility for all of its stateful data. It's not just responsible for its compute. It is the system of record for that data. So your data actually runs in the application, and then Akka will persist that data behind the scenes, but that's Akka's responsibility to manage that. Where that data goes, how that data goes, that's an independent concern. And so the application itself becomes its own living organism. It has responsibility for its own SLA, and it's constantly adapting towards achieving that SLA. And when you do that, you get a system that's effectively self-healing. It can move from one location to another because it might need to be able to do that. And then it also knows how to scale itself out. It becomes very elastic back and forth. And so what you end up getting is a system that can hold responsiveness indefinitely. And when you can hold responsiveness indefinitely, you start unlocking these amazing SLAs and these outcomes for that. And that was Jonas's approach, and that worked.
Fantastic. Thank you for this overview. And I guess the last question we should have, right, to round it up is obviously things are moving very, very quickly. I think you guys enter the field, hit the ground running, built on distributed systems, kind of adding agentic AI components, others. So basically start with the other end. Where do you see this field going? And as practitioners and as attendees of AI by the Bay, it's a learning conference. Where should they focus to kind of build the agentic AI future, which will be the one which we're going to build against?
Well, I think that where most people are at right now is they just need to keep doing experimentation and understanding what the different frameworks are that are out there and what their different direction and goals are. But what's going to happen here is over the next 5 years, I think we're going to see millions of agents that get developed. And those agents are going to probably be running in islands, pockets of intelligence that are throughout the enterprise. And they may be in different frameworks, they may be under different jurisdiction, whatever that regulatory regime might be. And in order for an organization to truly unlock the power of agents, you're going to be needing to find a way to combine those agents into some sort of cooperative mesh where, your employees can come along and say, I have this problem, I need this goal, I have this goal, and I'd like to be able to build an agentic system that makes reuse of the agents that are already there, but towards this sort of higher level goal, this higher level of abstraction. And so that is a type of enterprise orchestration that is a planning system that works towards goals, that works with all your islands of intelligences out there. And so I think that the future is this enterprise cooperation system. And really, in order to deliver against that, there's going to need to be some sort of agentic control plane, a global agentic control plane that can discover these islands, interact with them, combine them together and enable this sort of kind of these goals and outcomes that the enterprise wants to achieve.
Fantastic. I think that's actually sets a very good action item for our community, and we can talk about it at the conference, right? How do we interconnect all of these islands of intelligence? And probably that's going to be a distributed system. So, and you guys have a lot of experience with that. So thank you very much. Looking forward to your keynote and participation in AI by the Bay.
Thank you.